A lot of functions, quadratic functions, are not going to come in this vertex form, and so what do we do if we have that? Well, this second form is just the basic regular ax squared plus bx plus c. More probably what we're used to seeing, like in the quadratic formula. That's the setup, right? Ax squared plus bx plus c, a, b, and c. Yeah, this is a normal, basic, regular form. Okay, it's just ax squared plus bx plus c form. Okay, like we regularly see a quadratic in. All right. Well, as you can see there, that's not in the shifting form. I can't really tell how this is shifted in this form because it's not set up, you know, inside outside type thing. We could put it in that form, but that's not exactly how we're going to approach this. But one good thing about it is it's still a parabola, and that's still a, and so that still determines up and down, right? The x squared, whatever a is, whether it's up or down. So it's a parabola that opens up if a is greater than 0, opens down if a less than 0. A is negative. That still holds true. Okay? However, the vertex is not readable right off of this equation. Turns out what we're going to do in this case is, I'll refer to it as the vertex formula. If it's in this form right here, we're going to use the vertex formula to find the vertex. And here's what I mean by that. The vertex formula, the h of the vertex, you know, the vertex is hk. The h of the vertex is going to be found by formula. It's going to be minus b divided by 2a. Minus b divided by 2a. And I'll verify that this works. Do it different ways, but it just turns out that's what h is. You take whatever b is, do the minus of it, opposite of it. And then whatever a is, divide that by 2 times whatever a is. All right. Then the k, well, if you think about it, k is an x value, right? I mean, h is an x value. H is the x value of the coordinate of the vertex. And so k is just really whatever the y is when you have x as h. So let's just say k is f of h. Just plug in to find k. This just means to find k, plug in the h to be x. I mean the x to be h. H for x. Let's say it that way. Find k, plug in the h for x. So whatever you find here, whatever the number is, you're just going to plug it in. Plug it in for the x, and that's going to be your k value, the y value of your vertex. Okay? So this is this is the change when we have this form. Okay? All right. So let's do one. And there's a couple other points we'll find to actually graph it. Let's start with f of x, the graph, f of x equals x squared plus 4x minus 12. Okay? Well, we know it's a parabola. It's an x squared. And we know it opens, well, there's not a number in front of x squared, but it's understood to be positive 1, right? Yeah, there's an understood 1 in front of that. So this one does open up because that's a positive 1 in the front. Okay? Now, vertex, a little more complicated than if it was in vertex form. But to find the vertex, I'm just going to use that vertex formula, the h equals minus b over 2a. Minus b over 2a. Okay, so what's my b and what's my a here? Well, we already said a is 1. And this would be b, right? B is 4, and then officially that would be c, but you just need a and b for the formula. So what's this minus b over 2a going to work out being? Well, minus b, so do the opposite of b, be minus 4, divided by 2 times a, it'll be 2 times 1, so that's negative 4, divided by 2, it's negative 2. The h of the vertex, I can officially say here is negative 2, comma. How do I get the k? Well, like I said, this is the x value of the vertex, so I can plug that h in for x, and that'll give me k. Just do f of negative 2. Plug in, that's our notation, but what does that mean? That just means plug in x to be negative 2. So it'll be negative 2 squared plus 4 times negative 2 minus 12. And that's going to be k of the vertex. 4 minus 8 minus 12, negative 16. Is that negative 16? I believe so. So my vertex is, by these computations here, negative 2. The k is negative 16. All right? Okay, so let's put that over here. Well, let's move this up a little bit. All right, so we've got negative 2 and then negative 16. 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16. Negative 2, negative 16. Way down there. That's my vertex. All right. Now, what else am I going to want on this graph? Well, in this one, you know, the other form we just did the Y-intercept. On this one, I am going to want the Y-intercept. And it's actually pretty easy on this one. How do I get the Y-intercept? Set x equals 0. So that would be y equals, that would be 0 squared plus 4 times 0 minus 12. Works out nicely, doesn't it? Because that's 0, that's 0. So it's 0, 0 minus 12. So it's minus 12. So the Y-intercept is minus 12. So it's going to cross the y-axis here right about, negative 12 is right there. Y-intercept of negative 12. Now this form also, let's talk about the X-intercept. How do I get the X-intercept? Well, the X-intercept, you set the y to be 0, but in this case, what's y taking the role of y here? F of x equals 0. So to find the X-intercept, you set f of x to be 0. And that sets up a nice little equation that most of the time you can use factoring on. Here, factors up x and x, minus 12 and 4 in the middle, 6 and 2. One's a positive, one's a negative. I think it's positive 6 and negative 2, isn't it? Set those separately equal to 0. Subtract 6, you got negative 6. Add 2, you got positive 2. So those are my X-intercepts. Got a negative 6, and you got a positive 2 X-intercept. So it's going to cross the X-axis here at negative 6, sorry, and positive 2. Spread out a little more. All right, so really from those points, now notice if I draw in my X as a symmetry, it goes through the vertex. if I draw that axis symmetry, notice, yeah, that should be -2 right there. Those points are same distance away from that. But also over here, can I put another point, what about here? This has got to be a symmetrical point there, so see the parabola? I believe so. Okay? And, you know, we could fill in some more points just to be sure, but yeah, if we went through a table of values, this is, you know, we get the other points here and here and here, and sure enough, we'd see that that comes out to be the vertex. All indications seem to be that. All right, any question or concern? All right? All right. Well, let's try another then. Same thing. Let's graph a parabola f of x equals negative 2x squared minus 3x plus 5. Same thing. We're going to find open up or down, vertex, intercepts, x and y intercepts. Okay? All right, so parabola here opens down. Why so? Well, the A telling me it's negative, it's got to open down. All right, the vertex, well, it's not in the vertex form that we saw earlier, so we're going to have to use the vertex formula. The h is always minus b over 2a if it's in this form. What's that going to be? Well, b here is -3. The a, of course, is -2. Okay, so, but in the formula, it's minus b. Well, if b is -3, then minus b is going to be +3. It's the opposite of b. And you can write that all in there. You can say minus of -3 if you want, but it just means the opposite of b. Then I do 2 times a. Well, a is -2, so it's 2 times -2. What is that going to be? It's going to be 3 over -4, which doesn't come out quite as nicely as the h did in the first one. That's okay. Let's just, a lot of times we can just say, well, that's a decimal form of -0.75, isn't it? 3 divided by -4, -0.75. Usually a little easier to handle in decimal form. Okay? All right, so that's my h. How do we get k? Well, we get k then by plugging in that for x, right? Plug this in for x, and that'll get me what k is. So it'll be -2 times x is -0.75. So -0.75, we're going to square that. -3 times -0.75. Plug that in for x there, and then plus 5 on the end. And that puts me at what? Well, like I said, do this first. K equals -2 times 0.75 negative squared. It's going to give me a positive 0.5625. So that's what you multiply by -2 if you're putting them in separately there. Then we've got -3 times -0.75. What does that give you? 2.25 positive. So k winds up being -2 times that, 0.5625, plus 2.25 plus 5. I'm getting 6.125. Anybody else get that? Okay, thank you. 6.125. So what does that tell me? That tells me my vertex then is h is -0.75, comma, k is 6.125. So that's my vertex. 2, 3, how far I need to go out there, but it's negative 0.75, there's negative 1, so negative 0.75 there, and then 6.125. So I'm getting right about here. And it opens down, so it's going down from there. All right? What else do we say? We said the Y-intercept. In this form, it's an easy one to find that. How do we get the Y-intercept? Well, it's set x to be 0. 2 times 0 squared minus 3 times 0 plus 5. That's 0, so that's going to be a Y-intercept of 5. So it's going to cross the Y-axis here at 5. Let's talk the X-intercept. To find the X-intercept, you set y to be 0, but in this case it's f of x instead of y, so we set the f of x equal to 0, so we get 0 equals negative 2x squared minus 3x plus 5. Now, when we're solving this, my recommendation is, since these are, this is a negative x squared, my recommendation is, and we can do this on when it's equal to 0, can't do it to start with, but since it equals 0 now, let's move all these terms over here to the left, add the 2x squared, add the 3x, and subtract 5 from both sides, and long story short there, we wind up with this. Why do I do that? Because it's a lot easier to work with an x squared that's positive. Because then we can factor it. Should be able to factor 2x and x. See, minus 5, I believe you're going to have to put the 5 here and the 1 here, and a positive 5 and a minus 1. Not going to work. That and that's minus 2x. That and that's positive 5x. When you add it, you get positive 3x, which is what we wanted. With me? 2x plus 5, x minus 1. Is that okay? Well, that equals 0, so set those individually equal to 0. Subtract the 5, get 2x equals minus 5, divide by 2, so we get a minus 5 halves x-intercept. Add the 1 here, we got a positive 1 x-intercept. So the x-intercept here is negative 2.5. Negative 1, negative 2.5. And then we've got a positive 1 x-intercept. And if you want it looking real symmetrical, go ahead and put your other point, same distance away out here, same level. There you go. There's your opening down parabola. How about that? Your axis of symmetry there. I don't know. I'll have to draw that in, but could very well. All right. Look okay. All right. Do one more of those. All right. Let's see about this one. Are we okay on that one? All right. How about this one? Make a couple quick points about this one. I'll tell you what, I'll move it up. F of x equals 12x minus 3x squared, I said. All right. This one a parabola? Yeah. That's all we're talking about today, but I know it's a parabola because it's an x squared graph, x squared equation. Which way does this open? Up or down? Down? Got a 12 up front that's positive, though. But that doesn't matter, does it? It's what's times the x squared that matters. This one opens down because this right here is my a. A is what's times x squared. Doesn't matter if it's listed first, last, middle. Doesn't matter. If it's x squared, that's my a. That determines up or down. Got an a that's -3, so this one's going to open down. All right. Well, this one, too, matter of fact, even if they list it, my thought is maybe let's go ahead and put it in our descending powers. It might be a good idea to do that. So you can see it firsthand. It would be a -3x² plus 12x if I listed it descending power. Okay. All right. Because, yeah, then the vertex plays off of that too. To do the vertex, the h here, it's always minus b over 2a. It's the formula. And again, that's the a, that's the b. You leave it in this form. That's the a, that's the b. Yeah. A is what's times x squared, b is what's times x, no matter where it is listed. So that means b is 12, then minus b would be minus 12. A is -3, so this down here would be 2 times -3. How that works out nicely. -12 over -6, which is positive 2. With me on that? K then is, plug that in for x, either one. 12 times 2 minus 3 times 2 squared, or vice versa. That's 24 minus, do the square first, that'd be 3 times 4, it'd be 24 minus 12. So K is 12, isn't it? Vertex would be 212. All right, I'll go with that. All right, 212. Right there. 2. Right there. Okay. So there's my vertex. And it's opening down, so it goes down from there. Okay. What's my y-intercept on this one? Well, the y-intercept would be x is 0. That's 0, that's 0. So y is 0, isn't it? 0 minus 0. The y-intercept is 0. The x-intercept, well, the x-intercept, you set y, or f of x, equal to 0. And either way you go, whether it's this one or that one, how do I solve that? Well, that one has GCF. Yeah, this one's GCF factoring. You got a 3x common factor, so we'll pull out a 3x. That'll be 4 minus x. Set those separately equal to 0. Divide by 3 here, you got x is 0. One x-intercept, and here let's, well, either way, add the x or subtract the 4, but either way you get 4 is x. So we got 4 and 0. We've already got the 0, but 4 and 0 there. So we didn't get nearly as many points on this one, but I think we can handle it because the parabola, that's got to be the vertex, so it's got to come out there and come down there. Scoot over a little bit. Yep. How's that?